All right, today we are solving systems of equations by substitution. Last time we learned how to solve a system by graphing, but what happens when we graph an equation and our lines do not meet on our grid? Now clearly these lines are going to meet at some point, but we need a larger grid to actually see where they cross. So we need another method. And one of these methods is called substitution. So when I'm given two equations, as we learned early on in the year, substitution means just to substitute something in for what it's equal to. So in this case, y is equal to 4x. So we are going to substitute in 4x for y. From there we have a two-step equation that we can solve. 1x plus 4x is equal to 5x. So we have 5x is equal to 5. From there, I can divide both sides by 5 because 5 is multiplying to x, and we get x is equal to 1. Now, as we learned in graphing, we need a point as our answer. So now that I have the x, I can take that and substitute back in for what x is into either equation. So we get y is equal to 4 times 1. So y is equal to 4. So our point is 1, 4. Now, if we really want to make sure that our answer is correct, we can go back and plug back into either of our original equations and see if our answers are true. So we get 1 plus 4 is equal to 5. 1 plus 4 is 5, so therefore 5 does equal 5. So here's another one. I've got y is equal to 2x and x plus 3y is equal to 21. So again, y is equal to 2x, so I'm going to substitute in the 2x for y. Now in this problem, we have 3 multiplying to y in the second equation. So I have to multiply 3 to the 2x. So we get x plus 3 times 2 is 6. So we get 6x is equal to 21. 1x plus 6x is 7x, which is equal to 21. Divide by 7, and x is equal to 3. So now that we have that, we can go back and find y. And I have y is equal to 2 times x. So we get y is equal to 2, while my x is 3. So we get 2 times 3. So we get y is equal to 6. And again, if we really want to make sure we're right, we can go back and check. Okay, in this problem, notice the difference. I have x is equal to instead of y is equal to. So in this, instead of plugging in for y, I'm going to plug in for x. Now again, just like with the previous problem, we have a number multiplying to the x, so we have to multiply to what we're plugging into. So 3 times negative 4 is a negative 12y, plus 2y is equal to 20. Negative 12 plus 2 gives me a negative 10, equal to 20. And because the 10 is multiplying, we can divide. And we get y is equal to a negative 2. Now that I have y, I can go back and solve for x. And we get x is equal to negative 4y, or x is equal to negative 4 times negative 2. So x is equal to 8. So our point is 8, negative 2. Remember, when writing a point, you always write x first, then y. Don't get confused because we solved for y first instead of x this time. All right, so I'm going to, again, substitute in. Just replacing the y with what y is equal to. In this case is 3x. So I end up with 2x plus 3x is equal to 15. Add my like terms, so we get 2x plus 3x is 5x equal to 15, and divide by 5. X is equal to 3. Take and plug back in, and we get y is equal to 3 times 3. So we get y is equal to 9. So my point is 3, 9. All right, on this last problem, notice I've got y equals on both of them. So it honestly doesn't matter which way I solve. So because y is equal to 4x minus 1, I can replace into the other problem with that. Now this problem looks slightly different, much more like our multi-step equations we had back at early on. So first thing I need to do is get my x's on the same side. So I'm going to subtract 2x from both sides. 4x minus 2x is 2x, minus 1 is equal to a negative 5. Now that I have my x's on the same side, get x by itself, add 1, we get 2x is equal to a negative 4, and divide by 2, we get x is equal to a negative 2. Now that we've got x, we can go back in and solve for y. Now, it doesn't matter which problem I solve for. So we get y is equal to 2 times a negative 2, because x was negative 2, minus 5. Y is equal to negative 4 minus 5. Y is equal to a negative 9. So my point is negative 2, negative 9. Just to wrap things up, remember when we're solving a system of equations, we are looking for the point where two lines cross. So remember, that's the whole goal of solving a system, is to figure out where they're crossing at.